So we started the recording for today's lecture. We are extremely late. I forgot about today's class. Shit happened. So we might not have too long of a class, but whatever the time that we have and the people that we have, we're gonna continue. So this is the first request problem that we are solving for today's class. Copper synthesis is a radioactive isotope when your nucleus of copper synthesis decays. The emissions include beta minus particles and gamma ray photon. The count rate produced from a sample of the copper synthesis is measured using a detector and counter as illustrated in figure 13.1. So you have this thing. Question says that state 3 reasons why the activity of the sample of copper 66 is not equal to the measured count rate. Why the activity of the sample of copper 66 is not equal to the measured count rate. Where did they measure it? The nucleus of copper the count rate produced from sample and okay. So let's try to understand the wording of this question. It's important you have to first understand the question. What they're saying that state 3 reasons why the activity of the sample of the copper 66, so the exclusive activity that is coming out from the relative sample of this copper 66 is not equal to the measured count rate. So whatever that is measured in this detector is not the actual count rate of this thing. Why is that? I can already think of two reasons, but I cannot think of a third reason. The first reason that I am thinking about is that this is a lead shielding and we have kept the copper relative sample over here. And this is practically spreading out its radiation in all three-dimensional angles. So it is spreading out like a grenade getting blast. So something like this, going in all directions. We have only kept the vertically upside open, and we are taking out a small portion of this radiated out radiation, emerging radiation using this detector. So that this detector is definitely not detecting all the individual radiations which are coming out from the sample. If we had to do that, we have to place a very high number of radiation counter around the whole thing and hold this object maybe by semi-automatic levitation process or something, which is pretty difficult to achieve but not essentially impossible. So in this case, a lot of the radiations which are not going through the detector is going in left and right and in some other directions. They're not getting detected. So we are only detecting a fraction of the total radiation or ionizing radiation emission. That's one point. The second point that I can talk about is that obviously every environment has some background count. So this detector, additional to the fraction of the ionizing radiation that this detector is receiving from the radioactive sample, these detectors might also receive some significant radiation from the surrounding. So background radiation could be another reason. You might talk about the background radiation, but I cannot think of a third reason. What can there be? Let's have a look at the Mars scheme because I really honestly cannot think of a third reason. Maybe if I take time, I might come up with a third reason, but it's quite unlikely. Things usually pops. Multiple possible counts from each decay. Oh, yes. This is a good one. This question is saying us here in this case that when one nucleus of copper 66 decays, the emissions include beta minus particle and a gamma ray photon. So each individual decay is giving out two outcomes. Now there is no saying or there is no specific indication that both of these radiations will happen in the same direction and we will get over here. It is possible that the beta radiation might receive here, gamma photon might not receive here. Maybe both of them will not be received. So you cannot simply, logically speaking, if you whatever you count over here, you cannot simply divide it by 2 to get an average number of this decay count of the total decay count, because you cannot have a control in which direction this beta minus particles short, which direction the gamma ray photon short. So if both of these things get absorbed, you're gonna have 2 counts, but practically that 2 count came from a single nuclear breakdown. If you got one, well, 1 for 1, but if you don't get any of them, you basically lost it altogether. So because multiple possible counts from each decay, multiple possible in this case basically means 2 count from each decay, that can lead to some wrong calculation. Radiation emitted in all directions, this is something that I talked about. Dead time of counter. What is the dead time of a counter? I don't know what this thing is. I have to look for it. Okay, daughter product unstable and also emission of this is something that they have not said. They have only said that when a nucleus of copper 66 decays, the emissions include these two. So what is produced out of this emission product, and if that whether that product is also radioactive or not, it will definitely have a longer half-life. It will be more stable, that we know from our discussion from radioactivity. The binding energy per nucleon will be stronger, but it is possible that it is also a radioactive isotope with a longer half-life. So that might also undergo subsequent decays, and that might also be recorded over here. So that's also a possible source of error. Yes. So daughter
Sir,
product will be unstable or also emit radiation acquainted to the শেষ করে নেই. Self-absorption of radiation is sample of absorption or air or detector window. Okay. Self-absorption of radiation in sample or absorption in air or detector window. এই জিনিসটা মানে হচ্ছে this needs a bit of drawing. If you think
Sir,
about
what is the dead time?
dead time টা কি আমি জানি না, আমি গুগলে দেখি আলাপ করতেছি, dead time টা আলাপ করি নাই. I really don't know what dead time is.
sir, dead time is the minimum time for like between two counts to occur
Oh, yes.
for them to count as two separate counts.
ওই যে একটা হাই ভোল্টেজে পিক করে তারপর আবার ড্রপ করে একটা লোয়ার থ্রেশহোল্ডে আসার পরে তারপর আবার হাই ভোল্টেজে জাম্প করতে হয়, দ্যাটস দ্য থিং, রাইট?
I don't know about that, sir, but I just Googled it and the first result is
ডেড
like
টাইমে
minimum time.
ডেড টাইম এক্সপ্লেনেশন দেখাবো আমি, আই রিমেম্বার দিস থিং, ডেড টাইম এক্সপ্লেনেশন দেখাবো, ডোন্ট ওয়ারি। আমি লাস্টের পয়েন্টটা একটু আইকে দেখাচ্ছি, ডেড টাইম এক্সপ্লেনেশন বলতেছি একটু পর, মনে পড়ছে। লাস্টের পয়েন্টটা হচ্ছে যে এটা যে সেলফ অ্যাবজর্পশন অফ রেডিয়েশন ইন স্যাম্পল অর অ্যাবজর্পশন ইন এয়ার অর ডিটেক্টর। এই পার্টটা তো বুঝছো যে এই জায়গাগুলোতে কিছু অ্যাবজর্পশন হতে পারে, বিকজ we are having alpha radiation coming out. Alpha radiations are very susceptible to absorption. The other things, what is self-absorption means is something like this. Let's say we have this is the whole relative sample of the copper 66. So we have a relative nucleus over here. This one breaks. This one undergoes relative decay. I shouldn't use the term breakdown because it undergoes relative decay. And let's say it shoots out one alpha particle in this direction and one beta particle, gamma radiation in this direction. Gamma radiations are actually very light. They're very small, so it might, in all sincerity, it is possible for the gamma radiation to penetrate out. But the alpha radiation, if it is shot to inside the material, towards the inside of the material, or even if it is, or even from some material, if it is shot from outwards, but if subsequently there is another atom present, these alpha particles might get stopped and absorbed within this lump itself. So all the decays that is happening from all over the lump, inside, outside, at the surface, you're definitely not going to be able to get the information about all the individual decay from the outside. If you really have to have the decay of all the relative information, I don't know how it's possible to achieve, but what I can tell you, because many of these decays would, many of these ionizing radiations would get absorbed because they're alpha particles, they don't have very high penetrating power. So it's quite impossible for us to get all the information properly. So that's another information. আচ্ছা, ডেড টাইমের পার্টটা হচ্ছে এরকম। এটা তো হচ্ছে মনে করুন আমাদের ক্যাথোডের অসিলোস্কোপ। ক্যাথোডের অসিলোস্কোপের বাইরের পার্টটা হচ্ছে অ্যানোড, সরি ভেতরের রডটা হচ্ছে অ্যানোড, হাই ভোল্টেজ পজিটিভ রড, এন্ড বাইরের এই এন্ডটা থাকে হচ্ছে ক্যাথোড বা হাই ভোল্টেজ নেগেটিভ এন্ড, এবং মাঝখানে এখান থেকে তার দেওয়া থাকে। whenever these anode detects a small current, then it gets it as a single count. But there is a certain, the way this detection works is that this thing is kept at a very high voltage, very high positive voltage. Whenever this thing receives a single current, this thing drops down, and then it has to once again rise to the maximum value, and then it is prepared to receive the current, receive the second detection once again. So the moment it receives one free electron from the ionizing radiation that happened from the separation of the radon not argon gas that we have in the chamber. So once the voltage drops from the highest value, and because of the absorption of a electron, it drops to a lower value. I don't know exactly how much value is that. and then it has to rise up back to the original positive value, and then it can detect another sign. That there is a delay between these two things happening. So you can detect a certain, maybe maybe it will stay in this voltage for a long time, no radiation is detected, then you receive another one, and then it has to rise up once again over here. So if this rod received any of the electrons from the argon gas within this period or within this period, that will not be detected as a count. This is the part that we call dead time. For different designs, this dead time can be as small as microseconds or picosecond or nanosecond levels, but there is a duration for the detector mechanism for which it cannot detect the uh, received electrons. So if we have some reception in that part, that is a default problem of the detector mechanism that we have. We simply cannot do anything about this, but this is one of the sources of error for our calculation. That's what they mean. বুঝে গেছে
স্যার
আইডিয়াটা বুঝে গেছে বলো
স্যার ভোল্টেজটা কমতেছে কেন এখানে?
কারণ this central anode is kept at a very high positive voltage to do the attraction. Electromagnetic ionizing radiation comes in and it ionizes one of the argon atoms. So one electron is freed up and the positive charge goes to the boundary and becomes neutral once again. These electrons get absorbed into the positive anode. Whenever the electron is received, it suddenly receives a high negative charge compared to its high positive charge. I mean, the amount of electron is very small, the charge of electron is very small, but that significantly reduces the potential of this rod, because the electron would be absorbed in the rod completely and it will be eventually taken down to the battery side. That reduces the potential of this whole thing for a small duration. জিনিসটা হচ্ছে এরকম, আমি যদি ফিজিক্যাল একটা এক্সাম্পল দেই, যে লেটস সে ইফ ইউ আর ট্রাইং টু লেটস সে ক্যাচ মাল্টিপল বলস consecutively, let's say someone is continuously shooting you tennis balls and you're trying to continuously catch them. There is a duration as long as whenever you receive a ball from the point of your skin touching the ball to the point of deceleration and then dropping the ball, and then you are ready to catch the next ball. If you are shot multiple balls within the duration that you already have one tennis ball in your hand, you are most likely not to be able to catch it. This is something similar to that in mechanical terms, that the mechanism or the electromagnetic the voltage mechanism is simply not prepared to detect another electrons incoming. বুঝতে পারছি?
জি স্যার।
So it's just the limitations of the machine, sir.
It's a limitation of the machine. It's a default limitation of the machine.
Okay, sir.
Okay, so these were the parts over here. I'm pretty interested to see the examiner's report of this question as well, so I'm going to pull that up. 41 examiner's report is here. Let's have a look. Candidates were generally awarded partial credit for this question. Yeah, you don't say. They often understood the idea of background radiation adding to the count rate. Everyone understood the idea of background radiation. I mean, this is the point that everyone should write because this is from the O levels. People hardly forget this stuff. Which was uncommon to be awarded for any other possible reasons. Uncommon. So all the other things that the students wrote other than the background count radiation, they were pretty much BS. Mention of decay being spontaneous and random is not relevant. Neither the activity changing over time. No, these are the points which are not relevant for this thing. The shielding does not absorb radiation, but the count rate from the detector up to the position would be the same even if shielding were not there. So its existence does not influence the measured count rate. So these are the possible type of wrong stuffs that many of the candidates mentioned that they have written over here, because these are the factors which will not affect what is asked in the question. They have other effects, but not what the question asked. I think that made sense. Ono বুঝা গেছে clearly?
Yes, sir.
Beautiful. It was a good pick. Thank you. It's a nice question, discussable question. Well done. October, November 2017, 42. Question number 11A and C. Let's have a look at those. O and 17. Forty-two. Question number 11. All right, 11 এ তে বলছে, let me zoom in a bit. The circuit for a full rectifier using four for ideal diodes is shown in figure 11.1. So okay. This is supposed to be the positive output. This is supposed to be the negative output. Or a resistor RS current across the output AB of the rectifier. On figure 11.1, draw a circle around any diodes that conduct when the terminal X of the input is positive with respect to terminal Y. Draw a circle around any of the diodes that conduct when the terminal X of the input is positive with respect to terminal Y. So if X is positive with respect to terminal Y, let me pick up this picture. So if X is positive with respect to Y, so if this is the situation, let me use red. If this is the situation, then current is going to come out over here. It cannot go down through this path. It will have to go here. So this is one of the circles. And if this is working, I know for a fact this will be working as well. Because I know this because always the parallel diodes work for half cycle, and the other parallel diodes work for the other half cycle. So it comes down here, flows through here, and immediately comes over here, and then comes over here, and then goes back to the supply. And then it says also over here, label the positive and negative terminals of the output AB. So this will be our positive output for the terminal. This will be the negative output. So you just write those parts. You don't have to write plus and minus over here. I wrote plus and minus over here for my own reference, but you will be scoring marks over here and doing these two circles. বুঝা গেছে এটা?
So AB এর যে পজিটিভ নেগেটিভ ওটা
আচ্ছা, AB এর নেগেটিভ পজিটিভ নেগেটিভ হচ্ছে এভাবে যে দেখো এখানে যখন এটা পজিটিভ হচ্ছে, current is gonna coming out through here. Current is flowing through this path and it cannot go down here because it is blocked. So it's gonna flow through here, and this current is gonna enter the resistor R from this side. So current যেদিক থেকে ঢুকে সেটা হচ্ছে হাই ভোল্টেজ সাইড, যেদিকে যায় সেটা হচ্ছে লো ভোল্টেজ সাইড। তাহলে এই এন্ট্রি পয়েন্টটা হচ্ছে আমাদের পজিটিভ এন্ড আর লিভিং এন্ডটা হচ্ছে নেগেটিভ এন্ড। বুঝছো?
Yes, sir.
আচ্ছা, সিতে বলছে হচ্ছে, wow, this is a nice graph. The capacitor is now connected between the terminals AB of the output. The capacitor is now connected between the terminals AB. The capacitor is now connected between the terminals AB of the output. Achha. The capacitor reduces the variation ripple in the output to 1.6 volt. So here the ripple was happening from, how much is it? 5.6 volts, it says over here. The capacitor, reduces the variation in the output to 1.6 volt. Achha. Configure element to sketch the variation with time t of the smooth output voltage for time t1 to time t2. Suggestion explain if any of the resistor R in the capacitor connected between terminals. The capacitor reduces the variation in the output to 1.6 volts, which means that the drop will become 1.6 volt. So if I just take out this picture, I obviously also বুঝি নাই।
it will just go down to 4.
Yeah, that's the point. Yeah, precisely. That the ripple would be reduced by an amount of 1.6. So the new highest level would be 4 voltage. So if we add the capacitor, let me use maybe red. So 4 is right over at this level. So from 5.6, this is our maximum for this cycle. It's gonna go down to 4. So whenever it will reduce from here to here, this will be one of your cross point, and this will be one of your cross point, and this will be one of your cross point. This will be one of your cross point. So it only asked us to draw up to T2, so we don't have to essentially draw this one.
Sir, cross point for what actually?
Cross point for the finishing of the capacitor discharge curve, like that. It almost straight হয়ে গেছে, একটু ইয়া হলে ভালো হতো। তাও হতেছে না। আচ্ছা আমি এখান থেকে স্টার্ট করি। It's difficult for me to draw in this notepad. Yes, better. একটু নেগেটিভ এক্সপোনেনশিয়াল শেপ দেখাতে পারলে ভালো হয়, that way the examiner would know what you are doing, and the reason I'm putting the dot circles to convince the examiners to understand that what's going to happen. So basically the supply voltage is changing from the 0 and breaking up, but the capacitor voltage dropping only up to 4, and then it starts to rise up once again. So you just keep on drawing these other two parts at your convenience. এটা গেল একটা পার্ট। অনব এটা বুঝছো, ড্রয়িংটা বুঝছো?
Sir, question to reduces to 1.6 volt বলছিলেন, তাহলে ফাইনাল তো 1.6 হবে না?
দাঁড়াও কোশ্চেন দেখাচ্ছি। হ্যাঁ এটাই তো কোশ্চেন। কোশ্চেনে বুঝতে হচ্ছে যে না 2 না, 2 তো বলে নাই কোথাও। 2 বললে তো আমরা অলমোস্ট রেসপন্ড দিয়ে করতাম। The capacity variation in the output to 1.6 volt. The capacity reduces the variation, the ripple in the output to 1.6 volt. This means that the ripple was reduced to 1.6. Ripple basically means the up and down. So the ripple would be reduced by 1.6. Whenever without the capacitor, the ripple is altogether 5.6 because it is going all the way down and all the way up. Whenever you use the capacitor, the ripple reduces to 1.6, which means the ripple would be limited by 1.6. So we will still have the ripple happening for a value of 1.6 over here. So up to this 4, we have stable value. The ripple is limited to 1.6, not the whole output voltage.
Okay.
Okay, sir.
Huh.
Beautiful. আচ্ছা এরপর বলছে হচ্ছে suggest and explain the effect, if any, on the mean power dissipation in resistor R when the capacitor is connected between terminals AB. Suggest and explain the effect, if any, on the mean power dissipation on resistor R when the capacitor is connected between terminals AB. এইটা তো একটা ভালো কোশ্চেন। আচ্ছা, so if we do, yeah, there will be definitely a higher mean power dissipated. Yeah, the mean power dissipated would be bigger. I mean, I'm gonna write the answer in this fashion. Let me just show you. I'm gonna write that P mean equals to voltage mean squared divided by R. Basically, P equals to V squared by R. But I'm just simply adding the term mean because they use the term mean. So I'm gonna say that because the voltage is not reducing to as much before without the capacitor, the average voltage, the mean voltage available across the resistor R, the available voltage across the resistor R would be bigger than before. So mean power essentially increases according to the equation as stated above. That's what I'm gonna write. Average voltage টা যে বাড়বে সেটা কি বুঝতেছো? Because now the capacitor is working as a reservoir, so it is simultaneously charging up as the device is working. মানে why the power is increasing? I mean, there are many different ways to explain this, but one simple idea is when the capacitor is not connected, only the device is taking the energy from the supply. But when the capacitor is connected, the device does its let me choose blue. So the device takes its energy from the source for this much part of the circuit, for this much part of the duration, and within this duration the capacitor also charging. So now your energy taking from the supply is done by two components. The device is taking energy, and also the capacitor is also taking energy, because the capacitor would prefer to spend that energy in the next discharging cycle duration. So, and then your device takes up energy, and capacitor also takes up energy, which means now you have more energy taking up from the supply because you have two of the devices, and also the average voltage. In this case, the RMS value will be much lower, but here the RMS voltage is actually much higher. So essentially you have a much higher voltage output, which means you have a higher power. And that's how I would write the answer, but I'll have a look at the mark scheme to see how they would appreciate this answer. This is what, 11C. It says mean PD is higher or RMS PD is higher, capacitor supplies energy to resistor, so mean power increases. So they didn't bother to write the equation, they just mentioned these two factors. This is the state part, this is the explanation part. So yeah, it works. বুঝা গেছে?
Yes, sir.
স্যার এটা আরেকবার একটু বলেন তো, মানে
Sir,
স্যার মিন পটেনশিয়াল ডিফারেন্স যদি হায়ার হয়,
হ্যাঁ হ্যাঁ বলো।
so how is it actually relating? আর মার্ক স্কিমের পয়েন্ট
দেখো ইকুয়েশনটা দেখো, equals to v square by r না,
জি স্যার।
তো এখানে তো রেজিস্ট্যান্স চেঞ্জ হচ্ছে না, আমরা জাস্ট ভোল্টেজটাকে চেঞ্জ করে দিতেছি, বিকজ ওভার দ্য ডিউরেশন, ওভার দ্য টাইম আমাদের ভোল্টেজ ডিফারেন্ট একটা কার্ভ ফলো করতেছে কম্পেয়ার টু দ্য total modulated sine curve. So if you are increasing the voltage, essentially the power would also increase.
স্যার আমরা শুধু মিন ওয়ার্ডটা ইউজ করতে দিচ্ছি কেন এখানে?
We could have used the word RMS as well. Mean in this case mean that you have to understand that the voltage is not essentially constant. It's not a DC output. This is attempting to make it a DC, but it's not precisely a DC because the voltage is still undergoing some variation. So it is, I would not say it's AC. It is a variable DC. It is a variable DC. It is changing over time. So
Like the mean voltage increases because the graph does not fall below a point, like 4 volts.
exactly. It's not falling as much as before. Yeah, that's basically the reason. বুঝছো?
জি স্যার।
Okay, beautiful.
sir,
হ্যাঁ বলো আবিয়াজ।
can we also understand it in the way like the range is smaller, so the mean will obviously be smaller that way?
Range is smaller as in? Okay,
As
হ্যাঁ, I would say the range is higher.
well, yeah, it is higher at a higher position, but it doesn't vary between 5.6 and 0. Instead, it varies between 5.6 and 4.
That's precisely my point. What you said, what you're trying to mean is very perfect, but your choice of word might get you into trouble. Let me clarify you on this. If you say it's smaller, I mean, a smaller voltage might also be achievable if the voltage only varied over here. Let's say something like this. Let's say we could have a smaller variation in this part as well, if we could somehow achieve a variation like this, but that's also be a smaller variation, but that would give us a smaller mean power. So smaller variation is not the key part. The average value has gone up because the peak speed must remain at peak, so we have basically brought up the lowest point to a higher value. So smaller is the important bit, but smaller where? Towards the higher end. That's the important additional important information. বুঝছো কি বলছি?
G, sir.
এক্সামিনাররা এই ওয়ার্ডিং গুলার জন্য মানে টেক কেয়ার করে বিকজ দে রিয়েলি ওয়ান্ট প্রিসাইজ ইনফরমেশন। আচ্ছা, ফাহিম অনেকগুলো জিনিস পড়লো, সো দিস আর অল টপিক নেমস, সো আই উড অ্যাপ্রিশিয়েট সাম নাম্বারস।
স্যার ইম্যাগের একদম ফার্স্ট কোশ্চেনটা।
হ্যাঁ, তুমি তাহলে তো ইয়ার কি বলে ওই যে গ্রাফ বুঝো নাই। I'll help. No problem. এই ড্রয়িং
জি স্যার। স্যার এটা বলছিলেন যে আপনি নাকি মানে একটা ভিডিওতে মানে ভিডিও আপলোড মনে করছিলেন কিন্তু পাই নাই পরে ভিডিওতে আপনার একটা।
সমস্যা নেই, এখন আবার বুঝাই দিচ্ছি, নো বিগ ডিল। এটা হচ্ছে আমাদের ইনডিউসড, এটা হচ্ছে আমার প্রাইমারি কয়েলের কারেন্ট, আর প্রাইমারি কয়েলের কারেন্ট থেকে আমাকে সেকেন্ডারি কয়েলের ইএমএফ আঁকতে হবে। তার মানে হচ্ছে I have to attempt to draw this graph. E should be equals to minus d phi by dt. এটা হচ্ছে আমাদের বেসিক ইকুয়েশন। আর phi is proportional to b is proportional to I। এই সবগুলো হচ্ছে প্রাইমারি কয়েলের জন্য, প্রাইমারি। তার মানে আমাকে এই গ্রাফের নেগেটিভ গ্রেডিয়েন্ট এখানে আনতে হবে, এইটুকু আগে বুঝো। এই গ্রাফের নেগেটিভ গ্রেডিয়েন্ট এখানে আনতে হবে, এইটুকু বুঝা গেছে কিনা?
স্যার মানে ওই যে কারেন্টের তো ডিফারেন্স, ওই যে ডি থিটা বাই ডিটি করলেই তো ওই নিচের গ্রাফটা আসে।
হ্যাঁ, সেটাই করতে হবে। আমি ওই জিনিসটাই বলতেছি যে দ্যাটস হোয়াট উই আর ট্রাইং টু ডু।
জি স্যার, বুঝছি।
মানে এটা তাহলে কেমনে করবো সেটা দেখাই। মনে করো এখানে আমাদের ফার্স্ট পার্টটুকুতে আমাদের কোনো কারেন্টের ভ্যারিয়েশন নাই, তাহলে এই পার্টটুকুতে আমাদের ইএমএফ ইনডিউস হবে না, বিকজ কারেন্ট ইজ কনস্ট্যান্ট। ইফ ইটস জিরো তাহলে এই পার্টটুকু হবে জিরো, রেড মেবি গুড। এসেনশিয়ালি এই পার্টটুকুও হবে জিরো। আমি দুইটা জিরো পার্ট আগে ডিফাইন করে ফেললাম, বিকজ এখানে কোনো কারেন্টের ভ্যারিয়েশন হচ্ছে না। Zero gradient, zero gradient. If you have a look over here, you can see that this is a graph of decreasing gradient. So initial gradient is high, final gradient is low, and this whole thing is a positive gradient. If you try to think of the different tangents over here, you should get all positive tangents, positive gradient. The EMF that will be induced over here will be negative EMF. You'll have high negative EMF at the start and zero EMF at the end. So this EMF is going to change from here to here. How this change will happen, that we cannot essentially understand by the shape of the graph. This change might be a straight line change. This change might be a decreasing gradient. This change might be an increasing gradient. Any of these three lines would do. Most people go for straight line. You can also draw a straight line. But the point that I'm trying to make for the inclusiveness of the information is we cannot essentially ascertain that what type of change are we having. Although you can say we'll have a high negative EMF at the beginning because of a high steep gradient, and slowly that EMF will die off to 0 volt. এই পার্টটা বুঝছো কিনা দেখো।
জি স্যার।
আচ্ছা, এই পার্টের গ্রেডিয়েন্ট কিরকম? নেগেটিভ না? অনেক স্টিপ নেগেটিভ। তাহলে এই পার্টে আমাদের, এবং it is a straight line. If you hold up a ruler against this line, you'll find this is a perfect straight line, which means for this duration we'll have a constant positive output. Gradient is constant because it's a straight line, so we'll have a very high positive voltage. So there we'll have a pretty spike type of rectangle. এরপরের থেকে আবার এই পয়েন্ট থেকে আবার জিরো হয়ে গেছে, সো এখান থেকে আবার জিরো।
উপরের গ্রাফটা কি স্যার ফ্লাক্সের ছিল? ফ্লাক্স ভার্সেস টাইম?
কারেন্ট ভার্সেস টাইম of the primary coil.
আচ্ছা, মানে ফ্লাক্স যেহেতু প্রপোর্শনাল টু কারেন্ট।
Yes. বুঝছো? এটা কনভার্সন বুঝছো?
স্যার ওইটা যেহেতু নেগেটিভ গ্রেডিয়েন্ট, তাই হচ্ছে আমার এখানে পজিটিভ ভোল্টেজ পাচ্ছি।
এক্স্যাক্টলি, যে এখানে মাইনাস আছে ওই জন্য।
জি স্যার।
বিউটিফুল। তারপর
স্যার এখান থেকে এটাই। তারপরে স্যার এসএইচএম এর একটা সমস্যা ছিল।
আচ্ছা, বের করতেছি, ওয়েট, বুকলেট 1
আর স্যার এখান থেকে আমার একটা জিনিসের মানে একটা কনসেপ্ট ভুলে গেছি।
বলো।
নিম্যাক থেকে স্যার ট্রান্সফরমারে ওই যে বলে না যে একটা ল্যামিনেটেড রিং থাকে টু রিডিউস ফ্লাক্স, কি জানি মানে মার্স স্কেমে লেখা ছিল যে রিডিউস ফ্লাক্স লসেস নাকি জানি এরকম একটা জিনিস, বা টু ইমপ্রুভ লিংকেজ, ওটা জানি কিভাবে হয়
ওইটা
কনসেপ্টটা ভুলে গেছি একটু।
বলতেছি, মানে এইটার সাথে ল্যামিনেটেড ওয়ার্ডটা রিলেটেড না। দুই, আচ্ছা বলি, আমাদের ট্রান্সফরমারে মনে করি যে একটা ট্রান্সফরমার, এখানে যে সফটওয়্যার কোড দিছে, এই কোডটা যদি অল টুগেদার না থাকতো, মনে করি রেক্টাঙ্গলটা নাই, let's say the rectangle doesn't exist at all, we have the coil A and coil B only hanged in space or in atmosphere. In that case also some of the field lines of this coil would actually cut across coil B, but these field lines would get really spread out, ঠিক না?
জি স্যার।
The fraction of the field lines which would actually cut across the coil B would be very few. We are reducing that effect by providing a software and core. We are accommodating, or we are providing the magnetic field lines as easier to go by path compared to atmosphere. because the magnetic field lines will prefer to go through the soft iron core rather than going through the atmosphere. So as a result, most of the field lines, or a much significant bigger portion of the field lines, would follow through this soft iron core and do their cutting through the soft coil B. So your total flux linkage would become much bigger. মনে করো without the soft iron core তোমার variation of flux linkage যদি let's say delta B যদি মনে করো let's say it would be 0 through 3 হইতো, maybe with the soft iron core you might get your variation from let's say 0 to 20, something like that. এটা না করে there is another way to improve this thing further, which is actually done for practical purpose. সেটা হচ্ছে in practical transformers there is only one soft iron core, and there is an inside coil which works as the secondary, and there is an outside coil which works as the primary. So there is a single wire, and they are all insulated. They are all insulated from each other, and as a result you have the maximum amount of flux line cutting through here. এখান থেকে ফিল্ড লাইন বের হয়ে যাক বা কোনো ব্যাপার না, but as long as the field lines are produced within the coil, inside the coil you have all the field line flux line cutting across the coil. That's another way to achieve this thing as well. This is a practical reason. This is how really actual transformers work.
স্যার একটু পরে যাবেন ডায়াগ্রামটাই।
Sure.
স্যার এখান থেকে স্যার আয়রন কোর থাকলেও তো মানে কয়েকটা বের হয়ে যায় না লাইন, মানে
কিছু লস তোমার হবে. You cannot essentially make this 100% efficient. 100% efficient is a theoretical concept, but compared to this one, this is better.
আচ্ছা স্যার বুঝছি।
ঠিক আছে? So this is about the why do we need the soft iron core. The idea of lamination is important. If we have a setup like this, we can choose these wires to be bare wire because there is a gap between them. But if we use bare wires without insulation around the wire, we have to make sure that the soft iron core is coated with a insulator so that current doesn't get short circuited through this metal, because this is basically a metal. So you cannot essentially make current directly flow through this pathway to the output coil, because that will be short circuit. We want electromagnetic induction to work through the soft iron core, not the actual physical current. That's where the idea of lamination comes in. So either you have to make the soft iron core laminated, or you can make it the soft iron core open, and you can make each of these wire individually laminated. Either way, there has to be some presence of insulation between the coil wires and the soft iron core, and also the coil wires. ল্যামিনেশনের কাজ হচ্ছে শর্ট সার্কিটটা প্রোভাইড করা, আর সফট আয়রন কোরের কাজ হচ্ছে ম্যাগনেটিক ফিল্ডটাকে কনসেন্ট্রেটেড ভাবে মেইনটেইন করা. These are two different purposes.
জি স্যার বুঝছি। আর স্যার এসএইচএম এর কোশ্চেন নাম্বার 27B।
থ্যাংক ইউ
স্যার।
হ্যাঁ বলো।
সরি বি না সি।
বলো আবিয়াজ না কে যেন স্যার বলছিলা?
আমি বলছিলাম স্যার, আমি ভুলে গেছিলাম কি বলতে চাইছিলাম।
আচ্ছা সমস্যা নেই, মনে পড়লে আবার বলো, নো প্রবলেম। I'm here. 27C. Okay, this was a question where we had fixed mass placed on a plate, and we're making oscillation of this thing, and the cube was seen to be present over here. For a specific frequency, for a specific amplitude, we would see this cube to lose contact with the plate, something like that.
ইয়েস স্যার, তারপরে বলছে যে কোন পয়েন্টটাতে লুজ করে, ওই পার্টটা বুঝি না।
বলতেছি the amplitude of oscillation of the plate in B is gradually increased. The frequency remains constant. At one particular amplitude, the cube does lose contact momentarily with the plate. State the position of the plate in its oscillation at the point when the cube loses contact. মানে হচ্ছে এই যে অসিলেশনটা হবে আপ এন্ড ডাউন, exactly at which position of this plate the cube is likely to lose contact, at the equilibrium, or at the highest position, or at the lowest position. These are the three most likely scenarios. So কোন পজিশনে কিউবটা এখান থেকে টেক অফ করার পসিবিলিটি বেশি? What do you think?
Highest position.
Confused sir.
আচ্ছা বলতেছি, what you have to understand that whenever we are moving this cube, as long as the cube is connected with the plate. Why the cube is connected to the plate? Because its weight is still bigger than the required centripetal acceleration. So আমরা যখন উপরের দিকে উঠাচ্ছি, try to think about it.
এটা বুঝছি, মনে হয় হাইয়েস্ট পজিশনে হবে, কিন্তু কিভাবে এক্সপ্লেইন করব এটা বুঝি নাই, কিভাবে লিখবো?
আচ্ছা ওই পার্টটা আমি তাহলে বুঝাই। সেটা হচ্ছে একে দেখাই। Let's say this is the plate and here we have the cube. Here we have the cube. Now the acceleration equation goes by equals to minus omega square x, which means when x becomes the amplitude, a is mx. ঠিক না? So you would have the maximum acceleration required for simple harmonic motion at the highest amplitude. So let's say this is our step situation 1. Let me draw 2 more. পুরোটাকে নিচে নামাই ফেললাম, and I'm going to draw 2 more, one over here and one over here. Let's say these are the two extremities. এটা হচ্ছে আমাদের x equals to 0, এটা হচ্ছে মনে করো x equals to plus a, এটা হচ্ছে মনে করো x equals to minus a. You have to understand that for all of these positions, the cube has a fixed amount of weight working downwards. So এটা হচ্ছে মনে করো তার weight, এটা হচ্ছে তার weight, এটা হচ্ছে তার weight. This weight is always working downwards with the exact same value. When the plate is going upwards, in that scenario, the required simple harmonic motion acceleration is working downwards because a proportional to minus x. So when the plate is going upwards, this object, this cube, is gonna start to use a fraction of its weight as its downward required acceleration to maintain the simple harmonic motion. So মনে করো এটা weight যদি মনে করো 10 নিউটন হয়, এই পজিশনে সে ফুল 10 নিউটনই প্লেটের উপরে এক্সিকিউট করবে। যত সে উপরে যাবে, এই 10 নিউটনের part pieces is gonna keep on using it to make sure that the simple harmonic motion acceleration is provided and gonna apply the remaining amount of force onto the plate. ঠিক আছে, মনে করো হচ্ছে এই পজিশনে, লেটস সে এই পজিশনে আমাদের অ্যাক্সিলারেশন মানে সিম্পল হার্মনিক মোশন অ্যাক্সিলারেশন মনে করো হচ্ছে লেটস সে 6 নিউটন, but in this case working downwards. So this block is going to use 6 newton out of this 10 newton to maintain the simple harmonic motion and exert precisely 4 newton of force onto the plate, onto the plate right over here. যত আমরা দূরে যাব, তার এই as we go further above or further away from the equilibrium position, it is going to apply less weight onto the plate. এই কনসেপ্ট আগে বুঝো।
জি স্যার বুঝছি।
ঠিক আছে, so it is possible that there can be a certain amplitude where the acceleration is pretty much equal to 10 newton. That is the point where the weight will become momentarily weightless. The cube will be momentarily weightless, because momentarily weightless means that it will be using all of its weight to maintain simple harmonic motion, which means it will no longer be exerting any force onto this plate anymore. That is likely to be the point where the object or cube loses contact. If the cube rises even slightly higher than that point, we'll actually see the gap between them. But if the plate is risen exactly to that point, we should not see the gap yet, because that's the point where it is the boundary line, which means we still have contact, but the exerted force is 0. Two objects can be in contact without exerting force on each other. That's what is happening over here.
স্যার ফোর্সটা তো কমতে থাকে, রাইট? যেটা এক্সার্ট করে মানে as you go above.
Yes.
সো অ্যাক্সেলারেশনটা কি ওইভাবে চেঞ্জ হওয়ার কথা না?
Required acceleration for simple harmonic motion is increasing. That's why the exerted force on the plate is decreasing.
আচ্ছা,
স্যার উপরের পার্টটা বুঝছি, এখন নিচের পার্টটা খুললে কি মানে একদম অপোজিট হবে?
এইদিকে হলে কি হবে? হ্যাঁ, এদিকে হলে বুঝাচ্ছি। এখন এদিকে হলে আমাদের রিকোয়ার্ড সেন্ট্রিপিটাল অ্যাক্সেলারেশন ফর সিম্পল হার্মনিক মোশন হচ্ছে আপওয়ার্ডস, ওয়েট কাজ করতেছে ডাউনওয়ার্ডস, এন্ড এটা হচ্ছে আমাদের রেজাল্টেন্ট ফোর্স, তাই না? এটা হচ্ছে আমাদের রেজাল্টেন্ট মোশন। তার মানে হচ্ছে আমাদের এই কেসে আমাদের রিঅ্যাকশন ফোর্স কাজ করতে হবে হচ্ছে আপওয়ার্ডস, এখানে রিঅ্যাকশন ফোর্স কাজ করতেছিল আপওয়ার্ডস। মানে ফর দিস এন্টায়ার সিনারিও, resultant force was given by weight minus reaction force, because weight is working downwards. বুঝছো?
জি স্যার।
Weight is working downwards, which is the direction of the resultant force, and reaction force working upwards. So এই subtraction থেকে আমাদের resultant force আসছিল। But for this entire scenario, the resultant force will be coming from reaction force minus weight, because the reaction force will be working upwards towards the direction of the centripetal centripetal acceleration. For the centripetal acceleration, মানে simple harmonic motion acceleration, which is towards the equilibrium. So to make sure that this acceleration is gonna be available to us, r minus w, this will be the force equation for the lower part, which means r will r will always be bigger than w, and it will has to be as big as w, what is required for the simple harmonic motion, which means this, and try to think about it. If where does the r come from? R is basically the reaction force of the plate that from the pressing of the cube. So the cube presses the plate harder, only then the reaction force can become bigger. So as you go further down, because we're going to require a much bigger simple harmonic motion acceleration, this resultant force requirement will become bigger as you go further away from the equilibrium, which means r also has to be bigger. Weight is a constant, which means as you go further down, the cube will simply exert bigger force onto the plate. In other words, I can say that মনে করো যদি এরকম একটা সিচুয়েশন হতো, this is just an additional information just popped in my head. Let's say আমরা যদি এই কিউবটার নিচে একটা ওয়েট মেশিন এখানে বসাই দিতাম. Let's say we place the weight machine over here. Weight machine মানে বুঝছো বাথরুম স্কেল. And we took a high-speed video camera of this thing going up and down. We would see that when the plate is at the equilibrium, the reading of this thing is exactly the stationary weight of the cube. When this is slowly going up, the reading of this weight machine is decreasing. When this is going down, anywhere down, not necessarily going down, it can be going down and down. It is below the equilibrium position, this reading would have been bigger.
So এটা কি আজ আমরা যে ওয়েটলেসনেস পড়তাম লিফটের কেসে এরকম না?
Exactly, weightlessness is possible only at the highest position, where the weight is being used as the driving force of the simple harmonic motion, not the other way around.
জি স্যার, বুঝছি স্যার, থ্যাংক ইউ।
Sure. Abdul
So, sir,
contract is lost when weight
not weight, sir, omega square.
x is greater than g. Well, yes. Yeah,
So at the
I would say simple yes to this, but there is a catch. Catchটা হচ্ছে যে the moment when omega square x equals to g happens, that's when that's the end point till which the cube and the plate can still be in contact. The moment it gets bigger than this, the cube loses contact, which means in that scenario, the the plate is no longer commanding the cube to undergo simple harmonic motion anymore. The cube now has its own motion, free motion to be exact. It's gonna work like a vertically thrown object in the space, like a vertically thrown projectile. So if it is bigger, bigger can be a large range to be bigger. For all the range it is bigger, the cube is no longer affected by the plate. For all the range it is smaller, the cube is affected by the plate. For the equals to value, that is the terminal scenario. Bolo.
So equals to, not greater than or less than.
That's why I said yes, because for contact lost when omega square is greater than g? Yes. Is contact lost when omega square equals to g? Yes. Is contact lost when omega square x less than g?
Not less than g, but
less than g
equal
হলে
to G.
contact loss হবে না, but equals to g or greater than equals to g, contact would be lost.
Okay, sir.
Beautiful.
Sir,
Yes.
মনে হচ্ছে iron core ব্যাপার. Does it need to be? Why does the iron core need to be connected? Like, why can't we just use 2 iron bars connected to the coils?
So you are proposing that what if we don't have these stuffs, only 2 iron cores individually connected to the thing, and they are just hanging in the space, something like this?
Yes, sir.
Well, that basically is not of any benefit for us, because essentially what is going to happen, the coils would be producing their own magnetic field. Now what we're going to have, you're going to have the concentrated field lines up to the end point of this thing, but from the end point this spreading would still happen. You would pretty much have the spreading. You're not essentially stopping the spreading. The whole idea for using the iron core is so that most of the iron cores would most of the field lines would cut across this point. Whenever you have a continuous iron core, the field lines practically travel pretty much through the iron core. Few of them leak out, but that is very small proportion. Even if in this structure, if we had a little bit of, let's say, gap over here, let's say if I just try to undo all these stuff, let's say we had this whole thing, okay, and just for the sake of argument, let's say we're gonna make a bit of a gap over here like this much, and we're gonna have two horseshoe magnets facing each other to work as a core. What's gonna happen? Up to this point, the magnetic field lines are gonna be pretty concentrated, but at this point, they're gonna work like the way two bar magnets face each other in whenever they're faced. So you're gonna have a bit of spreading over here. And whenever they're getting spreaded, they are gonna be losing energy because of this spreading effect. Because to penetrate through the atmosphere, which is not as permeable as for soft iron core, for magnetic field lines, they're gonna have to spend some energy over here. So you're not gonna have the same number of field lines crossing across.
So for optimal focusing of magnetic field lines and flux linkage, just use the entire core.
We preferably use the entire core and something like this. We use a single core and wrap both the wires around the thing, one onto another one, so that we can make sure that the induction is the highest.
Okay, sir.
I can actually validate my point if I just go ahead to look up. Here you see, this is the part that I was talking about, or you can see over here. This whole thing is a core, and here you can see there are two different parts over here. So they are wound in this way, or you can see over here, this is the one integration. This is also this is a welding transformer. These are unique applications where you need to have really high voltage. I don't know why they use it, but these are carryable. You can see over here that we have a single iron core, and there it goes inside the iron core. I mean, this iron core is basically like a মানে মানে মনে করো হচ্ছে এরকম আয়রন শেপ, তার মাঝখানে হচ্ছে আরেকটা রড দেওয়া আছে, ওই রডের গায়ের ভিতর দুইটা ওয়্যার পেঁচানো। এই যে এগুলো হচ্ছে ট্রান্সফর্মার ওয়্যার। সো ইউ হ্যাভ overlapping windings around them which can work as your transformer. All of these three boxes that you can see over here, three cylinders, they are the transformer coil boxes. All of these three boxes have overlapping iron core windings. বুঝছো?
So is this to up the voltage or just concentrate the magnetic fields even more?
Well, it depends whether we're gonna up or go down the voltage. That depends upon the coil choice. I mean, the same transformer can be used for both purposes, depending upon how you connect it. But the purpose of the soft iron core is to concentrate the magnetic field lines. Yes.
Okay, sir. Thank you.
Sure.
স্যার
বলো।
স্যার ডিরেক্ট সেন্সিং এর নাম্বার 8B2
Beautiful. যাচ্ছি। Direct sensing এর number 8B2. Direct sensing. Eight B
Two.
2.
2 and 3
আচ্ছা দেখতেছি। So this is a question about a strain gauge. A strain gauge is connected in the circuit figure 9.1. এক মিনিট দাঁড়াও, I just have to. আচ্ছা, so এখানে বলছে হচ্ছে strain gauge is connected to the circuit in figure 9.1. We have a strain gauge over here with 1 kilo ohm. We are apparently applying two different voltages, V1 and V2, and we have two feedback resistors. So this is a circuit that is unknown to us. We haven't come across this kind of circuits, and whenever you have this kind of circuits, the working equation will always be given. So this is the working equation that they've already given us, so we don't have to bother about this. So এটা হচ্ছে আমাদের gain, এটা বসাইলে হবে। Number 2, there was a strain gauge is a resistance of 125 ohm when not under strain. Calculate the magnitude of V1 such that when the strain gauge S is not strained, the output V out is 0. আচ্ছা, আমি সেটা সার্কিটটা নেই। সার্কিট দেখা যাচ্ছে সবার? Is it
Yes, sir.
আচ্ছা, সো এখানে দেখো, এখানে বলছে হচ্ছে the strain gauge has a resistance 125 ohm when not under strain. So এই strain gauge for the time আমরা resistance জাস্ট করতেছি 125 ohm. Red is better. Calculate the magnitude of V1 such that when the strain gauge is not strained, I mean when there is a resistance of 125 ohm, the output Vout is 0. And Vout 0 হয় কখন? Vout 0 হয় যখন V2 আর V1 equals to হয়. So you can write in words that Vout is 0 when V1 minus V2, V2 minus V1 equals to 0 implies V1 equals to V2. So V1 আর V2 equal to হইতে হবে। সো আমাদেরকে বলছে হচ্ছে V1 এর ভ্যালু বাই করতে। সো V1 এর ভ্যালু বাই করার জন্য প্র্যাকটিক্যালি আমরা যদি V2 এর ভ্যালুটা বের করি, সেটাই আমাদের কারেক্ট আনসার হবে। সো V2 এর ভ্যালু বের করা প্র্যাকটিক্যালি ভেরি সিম্পল। V2 is basically the voltage that is used up by the 1 kilo ohm resistor. So we have two resistors in series, which is the supply 4.5. So we basically now use the potential elevator formula that V2 equals to হচ্ছে 1000 divided by 1000 plus 125 multiplied by 4.5 যা আসে ওটাই হচ্ছে তোমার V1 এর আনসার। বুঝছো?
স্যার V2 টা কি শুধু ওই 1 কিলো ওহম রেজিস্টারেরই মানে ভোল্টেজটা মাপতেছে?
হ্যাঁ হ্যাঁ হ্যাঁ, এই যে V2, এই যে এখানে দেখো যে 1 কিলো ওহম রেজিস্টার ভোল্টেজ থেকে তো এটাকে পুল করা হচ্ছে। So this output point is labeled as the voltage exclusively across the 1 kilo ohm.
আচ্ছা স্যার, হ্যাঁ হ্যাঁ।
আর 4.5 হচ্ছে আমাদের সাপ্লাই। সো 4.5 দিয়ে মাল্টিপ্লাই করে দিলাম, যা আসে এখান থেকে তোমার আনসার যা আসে ওটাই। বাট প্রথমে তোমাকে এই সেন্টেন্সটাকে লিখতে হবে। ইউ হ্যাভ টু সাবস্ট্যান্সিয়েট ইন ইওর আনসার দ্যাট V1 and V2 শুড বি সেম। আউটপুট 0 হইতে হলে V1 V2 যে সেম হইতে হবে এটা আগে তোমার স্পেসিফাই করে দিতে হবে ইন সাম সর্ট অফ ওয়ার্ডিং অর রাইটিং, and then you can go ahead and calculate the V2 and write that value as the answer of V1. That will work, but you have to first mention this is a this is a mark screwing information that you have to state that clearly. তৃতীয় বলছে in a particular test the resistance S increases to 128. V1 is unchanged. The ratio of RFR to is 12. Calculate the magnitude of Vout. এটা possible, simple. So আমাদের V2 এর রেজিস্ট্যান্স বের হয়ে গেছে হচ্ছে 128, সরি resistance of the strain gauge 128 হয়ে গেছে। V1 is unchanged. RFR2 ভ্যালু হচ্ছে আচ্ছা V1, তার মানে এটা ক্যালকুলেট করলে কত আসে দেখো তো, এটা একটু ক্যালকুলেট করে দেখো তো কত আসে।
স্যার 4 ভোল্টস।
It's exactly 4.0 volt. Good. So আমাদের V1 4.0 থাকবে and V2 টা চেঞ্জ হবে। সো যেহেতু আমাদের এই রেজিস্ট্যান্স চেঞ্জ হয়েছে তাহলে আমাদের শেয়ারিংটাও চেঞ্জ হবে। সো লেটস ক্যালকুলেট দ্য V2 ফার্স্ট ফ্রম দ্য ইকুয়েশন। V2 ইকুয়ালস টু হবে হচ্ছে 1000 ডিভাইডেড বাই 1000 প্লাস 128 ইনটু 4.5. Might as well prefer to write this in a bigger decimal fraction যাতে করে আমাদের পরে ভুল কম হয়। 1000
3.9894.
3.9894, beautiful. 3.9894 volt. So এটা গেল হচ্ছে আমাদের V2 এর ভ্যালু। এখন আমরা Vout কে এখান থেকে ক্যালকুলেট করে ফেলি। Vout ইকুয়ালস টু হচ্ছে 12 ভ্যালু বলে দিছে ওরা into V2 minus V1. V2 minus V1. So this one minus 4 into 12 আসে হচ্ছে minus 0.128 volt. Which is within the supply limits, which means this is the answer. এরকম আসছে না?
স্যার -127 আসছে, মানে 0.127।
আমার 0.127 আসছে আমার, কারণ আমি আনসারের ভ্যালু ইউজ করছি, আমি আর ওই ডিরেক্টলি এটাকে আর টাইপ করি নাই।
আচ্ছা স্যার,
ঠিক আছে।
আর স্যার 17 এর সি এর ডায়াগ্রামটা একটু সমস্যা।
An operation amplifier may be used as a part of the processing unit in an electronic sensor. State four properties of the cooperative circuit incorporating an ideal operation figure 9.1. আচ্ছা 5 volt Vin আচ্ছা গ্রাফ আঁকতে বলছো ওইটা
স্যার না এই গ্রাফটা পারছি মানে পরেরটা সি
ও এটা সহজ বলতেছি আমি output potential V out is to be displayed by using two light emitting diodes. A diode emitting red light is to indicate when V out is positive, and diode emitting green light is to be used when indicate when V out is negative. So common figure 9.2 show the connections of the two LEDs lights of the op amp. Each label is with the color of light that it emits. তো এখন আমাদের এখান থেকে আউটপুট ভোল্টেজের শেপটা কেমন আসছিল আউটপুট ভোল্টেজ শেপটা ছিল হচ্ছে এখান থেকে 5 পর্যন্ত ফিক্সড আবার 5 থেকে হচ্ছে এখানে -5 পর্যন্ত ফিক্সড এরকম না
স্যার হ্যাঁ
এরকম তো পজিটিভ আউটপুটের জন্য আমাদের একটা এলইডি গ্লো করতে হবে নেগেটিভ এর জন্য আরেকটা গ্লো করতে হবে সো আমি এখানে বেসিক্যালি আমরা আউটপুট থেকে আমরা দুইটা ওয়্যার দিয়ে দুইটা এলইডি এঁকে ফেলি সো একটা ওয়্যার পুল আপ করলাম one LED. You can give the circle or you can choose not to give the circle. Circle দেওয়াটা mandatory না. And then the other LED is gonna look the other way around. ঠিক আছে আর এখন কথা হচ্ছে যে যখন এটা পজিটিভ আউটপুট হবে তখন এটা গ্লো করবে কারণ এটা হচ্ছে 0 ঠিক না তখন এটা দিয়ে গ্লো করবে না সো এখানে বলছে হচ্ছে আউটপুট পজিটিভ হলে গ্রিন লাইট শুড বি এমিটিং সো এটা হবে হচ্ছে গ্রিন when the output is positive then current flows through here not through here when the output is negative then the current rise through here but not flows through here so এটা হচ্ছে blue নাকি red green একটা না সরি
উল্টা করছেন স্যার
উল্টা করছি হ্যাঁ উল্টা করছি আমি কোশ্চেন ঠিকমতো পড়িনি ভুল সরি এটা হবে রেড আর ওটা হবে গ্রিন
স্যার কারণ এটা তো 8 পোটেনশিয়াল তার মানে 0 ভোল্ট আছে এখানে তাই 0 আর এটা নেগেটিভ তাই হচ্ছে এখানে
প্রিসাইজলি কারেন্ট ফ্লো ডিরেকশনের উপর বেস করে আমাদের ডিসিশনটা আসবে
স্যার লাস্ট কোশ্চেন ছিল রিডাক্টিভিটি থেকে সরি থেকে ফটোইলেকট্রিক এফেক্ট
শিওর ফটোইলেকট্রিক এফেক্ট হচ্ছে বুকলেট 2 বলো
21 এর B2
So what is meant by the de Broglie wavelength definition? An electron is accelerated from rest in a vacuum to a potential difference of 4.7 kilovolt. Calculate the de Broglie wavelength of the accelerated electron.
স্যার এটা করছি B2
By reference to answer in one says why such electrons may assist with an understanding of crystal structure. The wavelength that you get over here is extremely small.
yes sir
This wavelength happens to be smaller than the typical gap between two consecutive atoms within a crystal. Because the wavelength of this wave of this electron is smaller than the gap between the two consecutive atoms within a crystal. This is why that gap can be properly seen, or those two atoms can be properly seen in that position. Like I said in the earlier scenario, if we want to see an object clearly, the light that we're shining on the object has to have smaller wavelength than the size of the object. If it happens, then the entire object's reflection would be available. If it doesn't happen, then it will have partial reflection available. As a result, the whole image cannot be processed.
স্যার মার্স স্কিমে ডিফ্রাকশন দিয়ে লেখা যে ইলেকট্রনস উইল বি ডিফ্রাক্টেড বাই দ্য ক্রিস্টাল
Hi. Problem is about the separation of the atoms. About, okay, can be used in electron diffraction. Briefly, analysts appreciate that the electrons should be reflected by the crystal because of their devolution now similar to the valence separation of the atoms. The crystal may answers alluded quite incorrectly into the frequencies with the makes similar in the value of the natural frequency of the crystal. What? Natural frequency of the crystal? Acha, anyway, this is wrong, so quite incorrectly. Okay, this can also work.
স্যার ডিফ্র্যাকশন হলে এটা কিভাবে ক্রিস্টালের স্ট্রাকচারটা বোঝায়?
This would come to the point that if you cut out the crystal in very thin slices, like as thin slices you can achieve, and then you produce the diffraction gating structure of this thing. Each of the slit separation, মনে করো হচ্ছে আমি একটা এক্সাম্পল দেখাই, মনে করো আচ্ছা, your question is not about the content of the question, your question is about how does that work, তাই তো?
জি স্যার, মানে ডিফ্র্যাকশনটা কিভাবে একটা ক্রিস্টালের স্ট্রাকচার বোঝায় এখানে?
মনে করো হচ্ছে এটা একটা ক্রিস্টালের ফেজ ভিউ, ঠিক আছে? ফেজ ভিউ মানে হচ্ছে এই যে অ্যাটম গুলো আঁকতেছি, অ্যাটম গুলোর ডেপথ ডিফারেন্ট, বাট তুমি একটা ফেজ ভিউ থেকে সবগুলো অ্যাটমই দেখতেছো। মনে করো ক্রিস্টালটাকে আরো বড় করি, ঠিক আছে? মনে করো এটা হচ্ছে একটা ক্রিস্টাল। এখন what we do physically, we're gonna one of the ways we can do this is that we can take a very thin slice that has to be done with very high care and very very good precise instruments. We can take a thin slice of this whole thing, then send lights through this thing and try to observe the diffraction gating pattern that we get over here. Other than sending lights through the entire structure, one smart thing can be that we can send light in one location and we get a pattern over here and can get some idea about the gap between the particles. Then we replace the source in a different location. We might get a different reading, and comparing the difference of these two images we're going to get from consecutive images, we can find out what is basically over here. This is something similar to the way our three-dimensional depth perception works by two eyes. Left eye sees a slightly different image than the right eye. When these two images get overlapped, we get the idea of depth perception. Do you know this works?
No, sir.
I'm not saying do you know this works, that not how, but in our brain these two images overlap and gives us directional viewing, something like that. So we can compare the difference of these images obtained for the light source being placed in different locations, and by compiling those data with some math, obviously there is some mathematical modeling and some algorithm manipulation, we can find out exactly at which location each of these individual barriers, which are the atoms are, and from that thing we can predict the structure of the atom.
Okay, sir. Thank you, sir.
আচ্ছা ঠিক আছে, it's 10:05. Thank you everyone for staying up this much late for me. We'll pick up more in the next class. Please problem নিয়ে হাজির হয়ো। আচ্ছা, Arnav give me another problem. So this is the last problem that we're going to discuss and then we'll call it a day. 10B1 photoelectric worksheet. Sorry Arnav, আমি তোমার প্রবলেমটা আগে দেখি নাই। Photoelectric worksheet. Ooh. Okay. Question 10 was stated in effect on each of the force given to the natural particle nature of the information for each individual levels are given. An emission spectrum is associated with the electron transition between these energy levels. For the spectrum, state the number of lines. Well, how many possible emissions can we get out of this picture? It's pretty simple. It didn't ask you to draw the things, but just to convince you of how many lines can we get out of this picture, I'm gonna draw these things. So if you have a look, we can get 1, get 2, get 3, 4, 5, 6. বুঝছো? অর্ণব,
Yes, sir.
so yeah, different people do it differently. I preferably always do it this way. I start from the one level, draw all the possibilities, and then let's choose the next level, draw all the possibilities. I slowly go downwards. Then you can simply count that how many possible downward jumps can you have of different energy values, and that's basically how many different photons might you get from these band gaps. All right, everyone. Thank you. Good night.